question of KSET 2015, which is based on solution of system of linear equations using numerical techniques. The question says, let A is equal to, it's a 3 by 3 matrix. The first row is 1 1 2, second row is 1 1 3, and third row is 2 3 4. And the matrix B is, first row is 2 2 3, second row is 2 2 4, third row is 9 8 7. Then we have something. Consider the following statements. The statement P1 says the matrix A has LU decomposition, and the P2 says the matrix B has no LU decomposition. Then which of the following statements is true? Option 1 says both P1 and P2 are true. Option 2 says only P1 is true. Option 3 says only P2 is true. And option 4 says neither P1 nor P2 is true. So they are asking whether A and B are having LU decomposition or not. So first we will consider A and B separately. So matrix A is 1 1 2. A is equal to 1 1 2, 1 1 3, 2 3 4. Now we find determinant of A. Determinant of A is equal to 1 into 4 minus 9 minus 1 into 4 minus 6 plus 2 into 3 minus 2. So this is equal to minus 5 plus 2 plus 2. This is minus 5. This is not equal to 0. So determinant of A is not equal to 0, and we will check all the leading principal minors. Leading principal minors for A. Here we have first leading A, this is equal to 1, and second one is 1 1 1 1. This is 1 minus 1 is 0. This is, and the determinant of A is equal to minus 5. And for B we will check. B is equal to 2 2 3, 2 2 4, 2 2 3, 2 2 4, and third row is 9 8 7. Now we find determinant of B. This is equal to 2 into 14 minus 32 minus 2 into 14 minus 36 plus 3 into 16 minus 18. This is equal to 2 into minus 18 minus 2 into minus 22 plus 3 into minus 2. So this is equal to minus 36 plus 44 minus 6. This is equal to 2, which is not equal to 0. Now leading principal minors for B. First one is 2, this is equal to 2. Second one is 2 2 2 2. This is equal to 0. And third principal minor is determinant of B. This is equal to 2. Now we have found all leading principal minors for both A and B. Here we can observe A is having a non-zero determinant and B is also having non-zero determinant. Therefore A is invertible and B is also invertible. A is invertible and also B is invertible. And also we can observe when we observe all the leading principal minors of A, then we have one principal minor as 0 in case of A and also one principal minor as 0 in case of B. Now we will use one important statement, that is, if consider invertible, suppose we have A as invertible matrix. Suppose A is invertible matrix, then A has LU decomposition. Then A has LU decomposition if and only if, it is both statements, both forward and backward. If and only if and only if all the leading principal minors are non-zero. All the leading principal minors are non-zero. All the leading principal minors are non-zero. So if suppose we have a invertible matrix, then it will be having LU decomposition if and only if all the leading principal minors are non-zero. LU decomposition implies all principal leading minus are non-zero. If suppose all leading principal minus are non-zero, then it has LU decomposition only for invertible matrix. Then we will observe these points in the A and B as well. Here determinant of A is not equal to 0, A is invertible, and leading principal minus are 1, 0, minus 0. This is not equal to 0, this is equal to 0, this is not equal to 0. There is at least one leading principal minus which is equal to 0. Therefore, A is not LU decomposable. A is not LU decomposable. Here in case of B, determinant of B is not equal to 0, A is invertible. Now we will check for principal minus. So leading principal minus, the one leading principal is value is 2, 0, 2. See here it is, there is at least one principal minus 0, is equal to 0. There is at least one principal minus which is equal to 0. Therefore, B is also not LU decomposable. So just it is based on one statement. Suppose we have a invertible matrix, then that matrix is LU decomposable if and only if all the leading principal minus are non-zero. Otherwise we can check if it is invertible matrix, then if all the leading principal minus are non-zero, then it is LU decomposable. So we can conclude that A is not LU decomposable and B is also not decomposable. Then we will check with the given statements P1 and P2. So P1 says A has LU decomposition. Just now we got A is not LU decomposable. Therefore, statement P1 is false. And statement P2 says the matrix B is not LU decomposable, has no LU decomposition. So not LU decomposition. LU decomposable means no LU decomposition for B. So therefore, statement P2 is true. So we will check with the options. P1 is, option 1 says both are true, it is not possible. Only P1 is true, it is not possible. And option 3 says only P2 is true. Yes, only P2 is true. And option 4 says neither. So the correct option is only P2 is true. Therefore the correct option is option 3.